Hello everyone. As a data analyst, sometimes you need to work with both structured and unstructured data. So you might find SAS Regular Expression is very helpful. So let me give you a few examples. For example, at work, sometimes you need to identify sensitive data. For example, the first one is the SIN number. In Canada, we use SIN number. In the US, they use social security number. So how do you identify SIN number, right? So you can try to Google online and try to find out, okay, the SIN number has maybe how many digits? 9 digits. And then, so the SIN number doesn't start with number 8, rarely start with number 9. So once you find those patterns, and you can put that as part of your code. So this regular expression will help you with that. The second part is that sometimes you need to identify the address. For that, you need to extract the postal code. So the postal code in Canada has start with one letter and then digit, another letter, and then there's maybe a space. Depends on the user input that or not, and then start with another pattern with the digit, letter, and digit, right? So how do you identify that in your programming code? And another thing is you might need to identify the credit card, or you want to find out if people put first name and last name, or last name and first name. So when they put first name and last name, they don't need to put a comma in between. But if they put last name and first name, they do need to put a comma to indicate the last name actually comes first. Can you really identify those patterns? So I'll show you this today. Another thing I want to mention is that sometimes you want to identify the date. For example, start with YYYY, MMDD. For those of you who don't know, that MM actually it stands for like 01, 02, so with a 0 in it, right? So if it's MON, it's more like a abbreviation of the full month. For example, for January will be JAN. So sometimes you might need to identify those patterns in your program. Just for your reference, that in the US, by default, so it's right by like the month and the day and the year. In Canada, we still follow the British system, so we go with day, month, and year. So that's something you need to be aware of. Most of the software we use, actually we use the US version of the software. For example, when we use Excel, most likely than not, we are actually using the US version of it, right? So those are the things that we want to identify. If you can think that for a couple minutes, and how would you do that in your code? But let me introduce you the SAS regular expression. So SAS regular expression basically is a predefined pattern and help you to identify like certain patterns in your data. For example, like this one with bracket, is basically find F, start with F, and then it's a bracket, and then this pipe means or, so you can either find U or BOO, right? So with this kind of pattern, when you define this pattern, you can find like full bar or a full bar, right? So you can so this helps you to identify certain kind of pattern. So you can also say I'm looking for some digits from 0 to 9, or maybe non-digits, or just space, tab, or new line, or just any character. So you can put those patterns in your SAS code and to identify the data. SAS uses the Perl regular expression. Perl is a programming language. I don't know which year that came out, but it was many years, probably 30 or 40 years or so. So it's very powerful. It's a very powerful tool, and here we only listed a few of them. But if you want to get more detail, you can search for Perl regular expression, which you can utilize that in the SAS. I'll give you a couple more examples. For example, this one, the dollar sign, right? So it means the end of the pattern matching. So this one, TER, so we'll match the winter because in the winter, the TER ends, the winter ends with TER, right? But not winter because winter ends with NER, right? So those are kind of pattern that you can use. You don't need to memorize all of them because if you work with another language, will be I won't say totally different, but most likely will be different. For example, you work with VBA or R or Python. They use different kind of pattern. So you just have a copy of this kind of patterns somewhere on your computer as a reference. If you ever need it, you can just pull them out and you can play around with it, right? So this again is very powerful tool. It's almost like programming. So to master regular expression, it takes some time, but whether it's worth it or not, it's really up to you. So again, you can have more patterns. Again, this is not a comprehensive list, but you can get some ideas. Same thing here. There's some redundancy between this one and the previous 3 slides, but it's try to give you more examples, right? For example, you can put square brackets, and basically means it matches any pattern, any character in that bracket. So they put a CA square bracket with T and R, so that will match either cat or car, but not like CATR, right? So you can use those patterns and try to identify the data. So let me show you the code. So in SAS, what you use actually is something called a PRX, which stands for Perl Regular Expression. You need to parse the pattern. So you look for, this one looks a little bit complex, but don't get overwhelmed with it. So you just take some practice, you get used to it. So basically looking for any character length between 1 to 32, and must begin with a letter underscore and followed by a certain kind of pattern, and then it ends here. So this is more a complex example of using regular expression. But if you search online, you can find something much more complex. If you know this really well, it saves you lots of time in terms of coding. But let me show you a couple of simple examples. For example, here, what I'm looking for is that I'm looking for a certain kind of pattern. So the pattern that, let's say I created a few models for risk. I created PD for probability of default, and EAD and LGD. So I'm looking for year and month and day. So I can find out how many PD models I created, let's say within a few years, right? Within a few years. So to search for this kind of pattern, I would put here just search for the year YYYY and MMDD, right? So in here, I made it very simple. So I put a 2. Basically, I'm looking for anything that start year 2000 something, right? So I start with 2, and I put a digit /D and a digit and digit. And for the month, so this is DD. Let me think about it. Okay, so this is 2000. Yeah. So this start with 2 and 2000 something, and the reason I put a 0 and 1 here because for this month, right? For the month, let's start with the 5th digit. So for the month, it can be either 0, basically from January to September, and then can be 1 from October to November. So that's why I put a 0 and 1 here. So this digit can be any digit, right? From 0 to 9, and same thing with the last 2 parts as 0, 1. Alternatively, I can put here because for like 0 here as maybe from 0 to 3, right? Because the day actually can start with 0, 1, 2, or 3, right? But I didn't get too much detail into in that. So so this will helps you to identify the pattern, and what it returns is the digit, the position. For example, in the first one, so this will give me 1, 2, 3. So this will give me 4, right? It give me 4. If I search for this data, so it will give me 5. Will give me 5. So give a try. You open your SAS program, give a try. And another thing, what you can do is something called regular expression change. So once you identify the pattern, you can change them to y, 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 mm, dd. So in this case, if I do the second part, right, so that will replace the 2017 0801 with y, 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 mm, and dd. Same thing with the second line. I can this also get changed to YYYMMDD. So why would I do that? Because once I change this pattern to this standardized pattern, so I can group them and I can find out how many PD models I created, maybe within a folder or between a certain time frame. Right. So this -1 means I'm searching for from the beginning all the way to the end, So let's say I have a couple of dates here in my source code. Let's say PD underscore 2017 0801 and underscore, let's say 2018 09 like 02, right? So that will replace both patterns. So -1 means search this pattern from the beginning all the way to the end. If I put 1, so that will only search once. So for this case, we don't have this happen one time, but this you can put 1, 2, search for 1 time, 2 times, or just as many times as needed until the end, right? So the file name actually is the same as this file name. So this first thing is you do a match, and if you do want to replace the pattern with some kind of pattern you define here, you can do that, but that's optional. Again, those are two separate things. So that's regular expression. Another thing is you can do is you predefine the pattern, So you create an ID. So let's say you put this kind of pattern, same thing as you see in the previous example. You put this one here, and you store that as this string regular expression, and you use something called PRS parse. Basically, use this function will create an ID. The same thing, because the computer need to translate this pattern to some kind of another type of pattern that computer can understand easily, right? So by translating that, it creates an ID in the memory, which makes the subsequent processing much faster. So you define it, you parse it, create an ID, and in the PRX max, you just use that ID. So the PRX match, you can either put the pattern in there, or you can use the ID. There are actually more PRX functions. Some of them only accept PID. Some of them, like this one, the match one, will accept both pattern and ID. So again, give a try. Another thing, what you want to do is, when you work with large amount of data, is that you need to put a /o. When you put a /o, the compiler only compiles this once. So if you don't put a /o, so because it's an internal loop, right? So when you do a set, you read one line of data, and then go back to the data and keep going like in circles, right? Like a loop, right? So in this case, we'll execute 5 times. If you put a /o, so this part, this compile part will only compile once, because it's the same pattern. You don't want to compile 5 times. So a good practice will be put a /o. So compile once, and that will save lots of time. Okay. Another thing I want to show you is that something called capture buffer. So I give you one example. For example, I want to swap the first name and the last name. Again, let's say this Lee and Catherine. Uh, so when you swap the first name, last name, you don't want to put a comma. When you see a comma, basically this means last name, and this means first name. So when you swap, you want to put the first name Catherine, last name as Lee. Right. So most people would do is that they go through this kind of function. So basically, you scan the name, right? And you take the second part. Again, the SAS start with 1, not 0. So the second part will be, in this case, will be Catherine. So that will extract the first name, Catherine. Use a comma as a separator. And then you scan name again, and you take the first part, which is Lee, and then you try to concatenate them together. You can either use a function, or you can use two pipes, so do the concatenation. So you put them together, you basically, it's kind of swaps, right? So if you use regular expression here, all you need to do is basically one line of code, and so what you do is you search for this kind of pattern with any characters, and with a comma here, and then the second part will be the same thing. Look for any characters. So once you find it, again, here is the PRX change, right? So you want to swap it. So this 2 actually means the second part. So this 2 means, you see the bracket, basically it's a grouping. So this $sign plus 2, it means this part, the second part. So the first one means the first part. So when you do the change, you basically change the position. You take this second part here, and you take the first part here, without that comma. So you can do more. Let's say if you have more grouping with bracket, you can put maybe 1, 2, 3, and you can change that. Position. So this is a simple example, but when things become much more complex, so regular expression can be very helpful. Again, this using one line of code. This is basically using 3 lines, unless you put the functions within functions. Okay, so I hope this will make clear. But if it's your first time using the regular expression, you might need to practice a little bit. So let's go back to our previous example and to see how we can identify those things. First is the SIN number. Like I mentioned before, the SIN number cannot start with the 8 digit for some reason. And then, but you can put some kind of pattern there. Say, okay, I want including I want the SIN number to be 9 digits, right? You basically put in 9 digits, and then say the starting digit has to be from 1 to 9, but not including 8, right? So that might help you to identify the SIN number. And then when you try to identify the postcode, basically you search for certain kind of pattern. Like I mentioned before, you search for like a letter and a digit and a letter. Maybe has a space, maybe not. So you have to take that into consideration. Same thing with credit card. You can search for the credit card. Depends on what kind of credit card you want to work with. For example, the MasterCards start with 5, right? And then the Visa start with 4. I'm not sure about the American Express or the Discover card. So you can find kind of pattern, like I think the credit card is 16 digits, right? So you basically do the best you can, right? It doesn't mean whatever you find will be credit card or SIN number, but with regular expression, you can try to you can do the first step filtering, and same thing with the first name, last name. You can search for this pattern. Again, I showed you the 2 parts that is in blue, which in blue. But if at work you want to find those information, you don't want to rely fully on the programming or the regular expression. What you want to do is you want to do a little research. For example, I can go to Canada Post to get all the postal code, right, from the website. And then try to match, and that will give you more or better result, right? Same thing with last name, first name. Maybe I can try to pull some common names or popular names from the Stats Canada, and try to use that list and to match whatever the name that we have in our data to identify whether that's a the last name, first name, or just it's not a business name, things like that, right? Same thing with SIN number, credit card number. Both of them have certain kind of patterns, which I was surprised, particularly with the SIN number. So actually, it's follows certain kind of algorithm you can search online, which is more mathematical thing. Same thing with credit card. So for example, for SIN number, if you live in Canada, what you can try. I tried on my own works, and I tried on some data, and also works. So basically, I did a little research because without that I wouldn't know, right? So without that I would simply look for 9 digits, which is probably not accurate. So this is just much better. So basically, you take a SIN number, right, and you multiply the SIN number by this number. So example. So let's say 1 multiply 1, right? So equal to 1, and then there's something about here is 6 times 2 is 12. So you need to add this together. So it's 1 plus 2 is equal to 3, and then I think you add all those digits together, and you come with a number. So if this number is divisible by 10, and then that's valid the SIN number. So I tried out my SIN number, but you can try on your own. So do little research before you try to find certain type of data. Will become very helpful. So in this case, I found this pattern actually by surprise, and then I coded this algorithm within SAS. And it really helped me to find the client SIN number. The reason I'm looking for those SIN number, address, or maybe phone number is that when you work with data, you have to be very careful about the security of your client data. So whenever you see those data, or you see someone who is coding the data, try to persuade them not to use them or store them, like the way it is, right? So what you can do some kind of scrambling, or do a mask, or put some kind of algorithm that hide the data after they use it, so they don't store the data just as the kind of plain text data, right? So that will help you to protect your customer data, just in case there's maybe a security linkage or something like that, right? So I hope this regular expression is helpful, and all the example I provided actually come from my work experience. I hope that will be helpful for you, if not now, maybe for the future. Again, thank you very much for listening, and hope you have a good day.